Hello everyone, welcome to a new lecture in the series of AI using Python. In this lecture, we will be discussing about support vector machines. Support vector machines or SVMs are generally used as a linear classifier. SVMs classify the data points by finding the best hyperplane which separates the data points from different classes optimally. In general, a hyperplane is the set of points x belongs to set R raised to n which satisfy ax plus b equal to 0. For a 2D case or x belongs to R2, the hyperplane will be a line, and for a 3D case, the hyperplane will be a plane. And in general, for n-dimensional data, the hyperplane is an n-1 dimensional linear surface. So here, this figure shows the hyperplane which is defined by ax plus b equal to 0. X is considered to be a 2D vector. Therefore, the hyperplane will be a line. We have for a 2D data set with variable x1 and x2, the hyperplane is defined by ax plus b equal to 0 or a1 x1 plus a2 x2 plus b equal to 0, where a1 and a2 are the elements of this row vector A. We have the weight vector A will be orthogonal to this line as shown in this figure, where the vector A divided by norm of A denotes the unit vector. Also, for points on one side of the line, we have ax plus b will be less than 0, and for points on the other side, ax plus b will be greater than 0. A separating hyperplane is the hyperplane which splits the n-dimensional space into two half spaces. Now, a set of data points are called linearly separable if there exists a separating hyperplane such that each half space contains points from a single class. In other words, the data can be perfectly grouped into two classes using a hyperplane. Let the labels be y equal to -1 for class 1 and y equal to +1 for class 2. In the case of linearly separable data, we can define two marginal hyperplanes, which are two parallel hyperplanes that separate the classes so that the distance between them is as large as possible. For example, in this figure, where we have two classes of data denoted by red color and green color, we have the data is linearly separable because we can find a separating hyperplane as shown here, and also these two marginal hyperplanes which are denoted by dotted lines. Now, the margin is defined as the minimum distance to the separating hyperplane to the marginal hyperplane, and the data points which are on the marginal hyperplane are called as support vectors. Now, for normalized data set, these marginal hyperplanes can be defined as ax plus b equal to -1, which is for class 1, and ax plus b equal to +1, which is for class 2. Now, if we consider all points in the class 1, in the case of linearly separable data set, we have ax plus b will be less than or equal to -1, and similarly for class 2, we have ax plus b will be greater than or equal to +1. And we have for class 1 data points, yk will be equal to -1, and for class 2, yk will be equal to +1. Therefore, these two conditions can be combined as yk into ax plus b will be greater than or equal to 1. We have yk into ax plus b will be equal to 1 in the case of support vector, and for all other points it will be strictly greater than 1. And here the distance between these hyperplanes will be equal to 2 by norm of A. Therefore, in order to maximize the distance, we have to minimize norm of A. This leads to the optimization problem for SVMs to find the parameters of the separating hyperplane which are A and B such that norm of A is minimized, subjected to yk into ax plus b greater than or equal to 1. So this condition basically implies that the data points in both classes will be separated. This optimization problem can be solved for finding the separating hyperplane using which the classes for a new data point can be predicted. Next, we illustrate SVM using a numerical example. We will start by importing the libraries. Now, here we consider an example with the data points comes from two classes, which is discussed in the previous lecture. So here the class 1 data points are denoted by xtr1 underscore 1 and xtr2 underscore 1. And the class 2 data points are denoted by xtr1 underscore 2 and xtr2 underscore 2. Similarly, the label corresponding to these classes will be denoted by ytr underscore 1 and ytr underscore 2. Now we will be plotting these data points. in which the class 1 data points will be plotted in green color and the class 2 will be plotted in red color. Here we have the plot of the training data, in which we can see that the data is linearly separable, where we can draw a line in between these two data points so that the data from both classes can be separated. Now we will be defining the model using the SVC function, and we will be training the model using the training data, which is consist of XTR and YTR. Then once we train the model, we can predict the output for the training data. Now we can plot the data points along with the separating hyperplanes and support vectors. So here the data points are shown in green color for class 1 and red color for class 2. This line shows the separating hyperplane, and these highlighted data points in green color and red color corresponding to the support vectors. That leads to the end of this lecture. Thanks for watching.